Today, we're talking about a James Webb Telescope discovery so incredible, it's reshaping how we understand the universe. Watch this video till the very end. What you're about to see will leave you stunned. Every night, when you look up at the sky, you are not seeing the universe as it is. You are seeing it as it was. Light from the nearest stars took years to reach you. Light from the farthest galaxies took billions of years. You are, without even knowing it, a time traveler, looking backward into the deep past every single time you glance upward. But here is what most people never consider. For all of human history, we have been blind. Two invisible walls have blocked our view of the cosmos. Walls so complete, so absolute, that we didn't even know what was hiding behind them. The first wall is cosmic dust. Vast, swirling clouds of microscopic particles that drift between the stars, absorbing and scattering visible light. Behind those clouds, entire stellar nurseries are hidden from us, places where new stars and planets are being born right now, completely invisible to our eyes and to every optical telescope ever built. The second wall is far more fundamental. The universe is expanding. And as it expands, it stretches light. Over billions of years, light that was once visible, bright, blue, energetic light, gets stretched so dramatically that it slides off the visible spectrum entirely, shifting deep into the infrared. Light that once carried the secrets of the earliest galaxies becomes invisible to us. For centuries, these two barriers kept the universe's greatest mysteries locked away. We never saw the first galaxies. We never witnessed the true birth of stars. We could theorize, we could simulate, but we could never look. Until Christmas Day, 2021. On that morning, humanity launched the most powerful observatory ever built into the cold darkness of space. A machine 10 years late, $4 billion over budget, and decades in the making. A machine that had been called, by the scientists who built it, the Golden Eye, the James Webb Space Telescope. And in just over 3 years of operation, it has rewritten what we thought we knew about the universe. This is that story. To understand what Webb has shown us, you first need to understand how it sees. Webb's primary mirror is 6.5 meters across, more than twice the diameter of Hubble's. But size alone isn't the revolution. The revolution is in the light it collects. Infrared. Webb doesn't just detect infrared light. It is specialized for it. Its instruments are cooled to temperatures just a few degrees above absolute zero, colder than the surface of Pluto, so that the telescope's own heat doesn't drown out the incredibly faint infrared signals from the cosmos. A sunshield the size of a tennis court keeps the instruments in permanent shadow, and the telescope orbits the sun at a point called L2, 1.5 million kilometers from Earth, where it can always keep its back to the sun, Earth, and moon simultaneously. The result? Webb can detect light that is 1 billion times fainter than anything Hubble could see. It can peer through dust clouds. It can see galaxies that existed when the universe was only a few 100 million years old. It can, in a very real sense, look back to the dawn of time. But Webb wasn't launched just to look far away. It was launched to look everywhere, and what it has found in our own cosmic neighborhood is just as extraordinary. Let's start close to home. Neptune. You know it. You've seen the photographs. That brilliant, deep blue sphere drifting in the outer solar system. But when Webb turned its infrared eye on Neptune, that familiar blue world almost vanished entirely. Here's why. Neptune's atmosphere is thick with methane, a gas that absorbs infrared light almost completely. When Webb looks at Neptune, there is almost nothing for it to reflect back. The planet goes dark. But this darkness is actually a gift. With the bright surface effectively switched off, something remarkable becomes visible. Neptune's rings, dusty, faint, and almost impossible to photograph clearly from any previous observatory, suddenly glow. They stand out in stunning, unprecedented detail against the black backdrop. We can see ring arcs that were never documented before. We can count moons we never resolved so clearly. 14 of Neptune's known moons are visible in a single image. These are the clearest photographs of Neptune ever taken, and scientists are still analyzing them, picking apart details that are only now becoming visible. But Neptune, remarkable as it is, wasn't the most exciting target in our solar system in 2025. That honor belongs to something far stranger, something that doesn't belong here at all. On August 6, 2025, Webb aimed its near-infrared spectrograph at Comet 3I Atlas, an interstellar object, a traveler from another star system, drifting through our solar system on a trajectory that will carry it back out into the void between stars, never to return. Interstellar objects are extraordinarily rare. We have only confirmed a handful passing through our cosmic neighborhood, and when one comes close enough to study, every telescope on Earth and in orbit wants a piece of it. Webb's job was straightforward: analyze its composition. What is this thing made of? What does it tell us about the place it came from? The answer was astonishing. 3I Atlas turned out to be extraordinarily rich in carbon dioxide and water vapor. The ratio of CO2 to water was among the highest ever measured in any comet, including the ones that formed right here in our own solar system. Think about what that means. This object formed around a distant star, in a region of that star's protoplanetary disk, where temperatures were cold enough for carbon dioxide ice to freeze out naturally. It carried within it the same basic chemical building blocks that seeded our solar system with the ingredients for planets, and potentially for life. Webb has now directly proven something astronomers long suspected, but could never confirm. The fundamental chemistry of planet formation is not unique to our corner of the galaxy. The molecules that built Earth, that built the oceans, that built you, those same molecules are being assembled around stars across the Milky Way. The universe is not special here. It is universal. If Webb can reveal secrets in our own solar system, imagine what it can do when hunting for planets around other stars. Alpha Centauri is our nearest stellar neighbor, a system of 3 stars just over 4 light-years away. For decades, astronomers have theorized that planets might orbit the 2 sun-like stars in the system, Alpha Centauri A and B. The problem? Those 2 stars are locked in a tight binary orbit, and their combined glare is so overwhelming that any planet orbiting them would be completely swamped by light. Webb solved this with a piece of engineering elegance called a coronagraph, built into its mid-infrared instrument. A coronagraph works exactly like the visor in your car on a bright day. It blocks the direct, blinding source of light, in this case the stars, and allows the eye to see what's hiding in the shadow. But even with the coronagraph, this was one of the most technically demanding observations Webb has ever attempted. The residual light from both Alpha Centauri A and its companion star B had to be painstakingly subtracted through meticulous image processing, layer by layer, pixel by pixel. What remained, after all that light was stripped away, was a single faint point, a ghost of a world. Webb has provided strong evidence of a planet, likely a Saturn mass gas giant, orbiting Alpha Centauri A. And here is the detail that made astronomers sit up straight. Orbital simulations suggest this gas giant follows an elliptical path that passes through the star's habitable zone. Now, a gas giant itself is not where you'd expect life, but a gas giant in the habitable zone of our nearest stellar neighbor means something profound. It means a planetary system has formed around Alpha Centauri, and where giant planets form, smaller rocky worlds with atmospheres, with oceans, with the potential for life, can form too. We may have just confirmed that our nearest neighbor has a family. We've seen the universe up close. We've seen it reveal its chemical secrets. Now let's watch it make something. The pillars of creation in the Eagle Nebula, 6,500 light-years away, are one of the most iconic images in astronomy. Hubble first photographed them in 1995, but it could only see the surface. The very dust that makes those pillars so dramatic also hides what's happening inside them. Webb sees through that dust, and what it found is extraordinary. Thousands of brand new stars, completely invisible to Hubble, suddenly appear still wrapped in the dusty cocoons where they were born. They glow as vivid red orbs, some only a few 100,000 years old. That red glow comes from superheated gas, blasting outward from each newborn star in powerful jets. Plasma collides with the surrounding cloud, and the collision burns. These pillars aren't sitting still. They are pulsing with activity, lit from within by violent births. But the most spectacular stellar birth Webb has captured is far from here, in a region called JWST 284, roughly 15,000 light-years away, on the far edge of the Milky Way. There, Webb found a protostar 10 times the mass of our Sun, unleashing two enormous jets of superheated gas in opposite directions. These jets span 8 light-years, nearly double the distance from our Sun to Alpha Centauri, bulldozing the surrounding cloud aside like a cosmic snowplow. It's one of the largest and most powerful Herbig-Haro objects ever documented. But what makes this discovery truly significant isn't the size of the jets. It's where this star is forming. JWST 284 sits in a region where heavier elements are almost non-existent, almost pure hydrogen and helium. That environment is a near-perfect mirror of the early universe, the conditions under which the very first stars ever formed. Webb is giving us our clearest window yet into one of the oldest mysteries in astrophysics. How did the first stars come into existence? Stars aren't the only things being born. Planets are forming too, right now, across the galaxy, and Webb is watching it happen in real time. Around a massive young exoplanet in the Kith B system, 625 light-years away, Webb detected something that has fascinated astronomers for decades: a circumplanetary disk, a ring of gas and dust orbiting a planet, the same kind of structure from which moons are thought to form. It is, in essence, a moon assembly line. Using its mid-infrared instrument, Webb delivered the first direct chemical measurements of such a disk, and the results were surprising. The disk is extraordinarily rich in carbon, packed with complex organic molecules like acetylene and benzene. But here is the twist. The disk surrounding the host star, the larger system in which this planet orbits, contained water but almost no carbon at all. Two disks, same system, radically different chemistry, and the system is only 2 million years old. This chemical difference allows scientists to compare the ingredients for moon formation in a distant system to what happened in our own solar system 4.5 billion years ago, when Jupiter's moons formed from a disk that may have looked remarkably similar. The universe isn't just making planets, it is making them in ways we are only beginning to understand. Individual stars, individual planets, but none of these stories happen in isolation. They all take place inside something far larger: galaxies. In 2024, Webb turned its attention to 19 nearby spiral galaxies, and the images are breathtaking. Take NGC 628, the Phantom Galaxy, 32 million light-years away. The blue at the center? Older stars, billions of years old, the galaxy's ancient core. But the red and orange threading through the spiral arms, that is where the action is. Glowing dust and gas, raw material. The brightest red patches are stars still being born, not yet free from the cocoons that made them, and scattered across the arms, giant hollow shells, some spanning hundreds of light-years. These are the scars of dead stars. When a massive star explodes as a supernova, the shockwave carves a cavity in the surrounding gas, pushing material outward and compressing it, potentially seeding the birth of new stars. Death fueling creation, destruction triggering life. Across 19 galaxies, Webb is showing us that this cycle, this endless loop of stars being born and stars dying, is the engine that drives the universe forward. From the ghostly rings of Neptune to a comet carrying the secrets of another star. From violent births inside dusty pillars to a protostar tearing through the edge of our galaxy. From moons assembling in silence to entire galaxies running on cycles older than time itself, Webb has shown us a universe that never stops building. It never stops destroying, and it never, ever stops surprising us. If this video left you wanting more, there is plenty more to come. Hit subscribe so you never miss a single discovery. And if you enjoyed this, leave a like. It genuinely helps this channel reach more people who love exploring the cosmos. I will see you in the next one.